it, Kara. We're going to learn it. Find the measure of exterior deviate. This is a little bit of a jump because we're learning this today. So we're going to just, if you don't know, just skip it. You can come back and look at that later. But what is the complement of an angle? Complement would be, Jenna? That would sum with this to be 90. And so that would be, good job, 73. And then how many lines can be drawn through N parallel to MP? Look at that down there.
1, 2, 2.
How many lines could you draw through this N point, this vertex here, this point? Only one, right? One that would be parallel to MP. Okay? So today we are going to find the measures of interior and exterior angles of triangles. We're going to apply theorems about the interior and exterior angle. So first, back to basics, triangle sum. The sum of the angle measures of all triangles, any triangle, is 180. Good. So in this diagram, we could say that the measure of angle A plus the measure of angle B plus the measure of angle C is 180. Good. So what type of a line? Oh, this is a name of a line that can be added to a figure to aid in a proof. What do you think, Matthew? Good. He did not know that from the top of his head, but he's a smart boy and he's looking at the book. An auxiliary. It's like a helper. If you are a part of an auxiliary council, like a lot of women who are like the women's auxiliary, they're the helpers. Okay? So an auxiliary line can be used in the triangle sum theorem. And so we're going to see that, look at, there are some angles inside the triangle. Do you see there are also some angles outside, exterior too? Okay, so let's look at this. After an accident, the positions of cars are measured by law enforcement to investigate the collision. They do the math. Use this diagram drawn from the information collected to find the measure of angle XYZ. XYZ. So we're looking for this little angle over here. And so, Kaylin, how will you find it? Okay, so don't think too hard. This is what we're looking for. And we know this is 62. And we know this is 40. We're simply looking for the third angle.
Okay, so you add 62 and 40 together.
And you get
subtract,
102.
And then you subtract that from 180, and it's just 78.
Good job, 78. Okay. So the number of degrees for that angle is 78. Okay, we're just using our angle sum. What we were just talking about, the triangle sum theorem. Triangle sum theorem. Okay, here we have a second question. Now they're looking for angle YWZ. So once again, are we able to use a triangle sum theorem? So what is it, Andrew? So you simply add the two known angles and subtract from 180. And it is not what you said. WXY. We're not looking for WXY. We're looking for this one, which should be 50. Okay? They're just finishing it here. Okay, let's use this same theorem to, on a map, find the measure of angle MJ. J is up here. Okay.
Wait, where's the J? Oh,
M, J. Okay. J is up here.
Okay.
Plugged in. This is kind of fun because MJK, this angle that we're looking for doesn't really jump out at you right away because we only know one angle here, right? And we're not even told that we know parallel lines, relationships, or anything like that. So we have to start where we do have enough information, right? And where is that? Where do we have enough information to find an unknown angle?
I see two parallel
Okay,
lines.
Sydney, this is the angle, you're right. So we're going to go find this. Oh, we do have enough information. I just saw these arches. Okay, so these arches are telling us that we do have parallel lines based on what theorem?
Alternate
Interior angle theorem. So anyway, we know then that
two lines are parallel.
These two lines are parallel. What can we say about this unknown angle, Sydney, that you were mentioning? Can you find it? Do you know it? What is it? How can you find it? So we were able to find this unknown angle based on our triangle sum theorem, right? We have a 44-degree angle. And now that we have this symbol over here, we know that this angle equals the one we just found, right? So it also is 44 degrees. And based on alternate interior angles, we know that this segment is parallel to this segment, don't we? Okay? But I don't even know if we need that so much as, there's so many ways you could find this angle. You could find it by saying that we have a 44 here, a 104 here, and with this angle here, with these other two, would sum up to what?
Oh, that equals two.
That would be a all linear, those would all be supplementary, the three of them together, right? They form a line. So, or we could say we have 104, we have 44, again the same ones, and we're looking for this final, and you could just use the angle sum theorem again, and it is? 32. Okay, so 32 degrees. Okay, so geometry is often like a chain of events. When you don't have enough information over here, you can work your way over there by starting where you do have enough information, right? Okay.
They did do it so that it was parallel.
They did. Okay, so here we have some corollaries. The first is the acute angles of a right triangle. The two smaller angles, right, of a right triangle must always sum up to what?
90.
And so we would say that they are
Complementary.
complementary. They're complementary. So in this example, D and E, those two angles, their sums are 90 degrees. We can also say the measure of each angle of an equal angular triangle, we've already said, is each angle is 60 degrees, right? And that's because all three angles are the same, and their sum is 180, so they're all 60-degree angles. Okay, so here's your question. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? Now, we don't know the number of degrees, but we know that this known angle, 2x, and the other acute angle have what? Together, they're complementary, so they have a sum of 90 degrees. So we could write this, right? The measure of angle A plus the measure of angle B, the two angles are 90. And now what could we do with the known information? Substitute. We can substitute 2x, and it doesn't matter what we call it, right? Although they've named the known angle A. So they've substituted it here on the left. 2x equals the measure of angle B, plus the measure of angle B equals 90. So just substitution.
But it has to be 45.
No. Well, what are we going to do next? Doesn't have to be 45 because we're not being told what this angle is. This expression is going to have a variable in it, right?
But if it says it's a right triangle. So
I know, so we know that one angle is 90. Here it is. You know, you could say it that way as well. But what do you do to isolate the measure of angle B? Subtract it, right? And there's your expression for the unknown angle. Okay? That's it. If we knew what x was, we could now give a value, but we don't. So there's your expression for the other acute angle. The measure of one of the acute angles in a right triangle is 63.7. So what would the other acute angle be? This is a little easier because we actually know the value of one of the acute angles, right? Okay, so tell us again.
You would do 90 minus 63.7.
That's correct, because A plus B will give you 90, so good. And you get, anyone agree, 26.3? Yep, there you go. So those two angles are complementary, so we just substitute the known value, and we find the value, okay? Okay, so here is the question that goes back to that warm-up. This angle here, this angle number 4, is outside of the triangle, right? So, well, first of all, they're just giving you a definition here. The interior is all of the set of points inside a figure. And of course, the exterior is all of the set of points outside the figure. This is cool because what can we say about angles 3 and 4? Together they are supplementary. And what can we say about angle 3, with angles 1 and 2? Their sum is, which is also, it feels like a supplementary group of 3 angles, doesn't it? So what can we say about 1 and 2 angles, the sum of angles 1 and 2? It equals 4, isn't that cool? So this is what we're learning today, is that this exterior angle, I'm sorry, okay, let's see what they have here. An interior angle is formed by 2 sides of a triangle. An exterior angle is formed by 1 side of the triangle and an extension of the adjacent side. So you can form an exterior angle by taking any side of a triangle and then just extending it straight out from that side. And now look at, with the other adjacent side, we now have this exterior angle, okay? So angle 4, because it's supplementary to 3, angle 4 equals the sum of these two. Because if you add them up, that number is supplementary to 3 as well. Okay? So angle 4 is an exterior angle, and it equals the sum of these far away angles. Because they're not close to angle 4, we call them the remote interior angles. So an exterior angle is going to be equal to the sum of those remote interior angles. Okay? And that's what this says here. Each exterior angle has 2 remote angles, remote interior angles. There they are, not touching, not adjacent to this exterior angle. A remote interior angle is an interior angle that is not adjacent to the exterior angle. So angle 4 is an exterior angle, and angles 1 and 2 are remote. And as I just said, the measure of this exterior angle is equal to the what? Sum. Good. And who can finish this statement? Measure of angle 4 equals, Sydney? Measure of angle 1 plus a measure of angle 2. Okay, so we just apply what we've just learned. So we know that this angle here, BCD, is what do we call that type of angle? Exterior. So we know that this expression equals what? Good, the sum of these two. Okay, and we could write this step by step. First of all, the given information is the measures of angles A and B, the sums of those angles equal this remote angle. And that's our exterior angle theorem. So now we could substitute, right? The known expressions, just substitution. And then they go through all these steps to solve. They're solving for x, but notice we're being asked to find the measure of angle B. So never forget, once you find x, plug it in, right? Does anybody have it? Is what?
39.
Did anyone else agree? Let's see if x equals 39. 39, did you divide by 3?
I subtracted 3x and 2x.
Okay, so 26 is what x equals. So when we substitute that, we have 26 times 2, which is, plus 3, which is 55. 52 plus 3 is 55 degrees. Okay? Do you understand what you're doing today? It's a short class, so let's take a quick look at the third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another, then what could we say about that final angle that they each share? That they would be congruent as well. So let's say that this angle L was 100, and this angle here was 30. Well, then this one has a 100 and a 30 as well, right? So do you see how they both would have to have a final angle that would sum that total to 180, right? Okay, so you may need to use that today as well in finding a third angle.
What are we supposed to do when they don't meet?
So do we see here we've got overlapping triangles, which I really love. But do you see that this triangle here has a very small angle H? which corresponds with GJI's very small angle G, right? And then we have in the left triangle an angle F, which corresponds with what in the right triangle? I. So now we know that because they both share those two congruent angles, that their third angles must be congruent. So we can set them equal and solve. Okay? And so let's just show real quick what happens when you do. We know that they're equal, so we set the expressions equal. And then we continue to solve. Y squared equals 20, so what are we going to do to both sides? Square root. And we'll take the principal root, because this is real world. We've got to have a length, not a negative segment, right? And so the measure of angle K is 4 y squared. Since y squared equals 20, look at that. They didn't even take the square root. They just substituted 20 for y squared. That's nice. And you have an angle that equals 80, which means J equals 80 as well. Okay? Okay, good.